All right, so one of the things that not many people know is that multi-signatures in Bitcoin. So actually Bitcoin supports multi-signatures since the beginning, and a lot of people doesn't know this because they use basic wallet software which doesn't allow them to create multi-signatures, okay? But actually Bitcoin supports this since the beginning. So if your wallet does not support this kind of procedures, you need a wallet software that is more advanced, okay? So let's look at, in general, what a multi-signature is and how it works in Bitcoin. So multi-signature protocols allow a group of signatures to produce a single signature on a message M. Verification of the validity of a purported signature can be publicly performed given the message and the set of public keys of all signers. Several use cases for multi-signatures exist, including low-trust escrow services and split device security. A trivial way to transform a standard signature scheme into a multi-signature scheme is to have each signer produce a standalone signature for M with its private key and concatenate all the signatures. So this is actually how it works for elliptic curve digital signature algorithm in Bitcoin, okay? So here the idea is as follows. For instance, for the low trust escrow service, you want to transfer funds to somebody else, but you have now an escrow service, so three people get together and sign M, the transaction. So you need three signatures. So if you use ECDSA A, then you have to provide three signatures. So everybody has to sign it. Then you have to, concatenate all of the signatures. But Schnorr signature solves this problem, so we will see it next. However, the size of such multi-signature grows linearly with the number of signers, right? So if 10 people signs it, then you have to have 10 signatures. Ideally, a multi-signature scheme should produce signatures whose size is independent from the number of signers and close to the one of an ordinary signature scheme. This is actually what Taproot upgrade provided to Bitcoin with the Schnorr signatures. So first, let's see how it was done traditionally. So let's see how multi-signature applications can be done. And next we will talk about Schnorr signatures. So these are some of the examples you can see from Bitcoin Wiki. So one of two, husband and wife petty cash joint account. So in this case, you have two signatures, husband and wife, but one of them is enough to spend the funds. So in this case, both parties trust each other, but any of the signatures can be used to spend the funds. So this is actually happens in traditional banking. You have mutual accounts and anybody can use it, but it can be different. So if you have a savings account and maybe you want to have decisions by both parties, then two of two multi-signature works. So in this scenario, both of the parties has to sign the transaction for it to be valid, okay? So as you can see, we can do M out of N signatures in many different scenarios. For instance, 2 out of 3, parent savings account for child. So here, 3 parties, the parents and the child. So we don't say here 1 because we don't want the child to spend money without parents' consent, but we say that one of the parents is enough to give the consent. So this is why 2 out of 3. So if the kid can trick one of the parents, then they can spend the money. 2 out of 2, two-factor authentication wallet. This is important because, sometimes people lose their devices. So in order to have better security, you can provide signatures with 2 of your devices, so that if one of your devices is stolen, they won't be able to use that device to sign a transaction. You need 2 out of 2. 3 out of 5, low trust donation address. For instance, you are especially if the donations are large, maybe you shouldn't give the authority to a single person. So 3 out of 5 might be a good idea. 2 of 3, again, buyer seller with trustless escrow. So here, one person sells something physically to another person. So there are 2 people, but you agree to work with a escrow service. So they become the third person. So first you make the transfer in physically, maybe you are selling a car and so on. And then you transfer the funds to an account. And if the seller really gives the device, the object physically, then the escrow service agrees with it and transfers the money. But if you don't give the physical object to the buyer, then the escrow service signs it with the buyer and gives the money back to them. So this is the idea. 2 out of 3, again, a board of 3 directors maintaining funds for their organization, which requires only 2 of them to sign it. 2 of 3, improved hot wallet security for businesses. Again, it is a good idea to not to give the all authority to a single person. 2 of 3, again, decentralized cold storage vault. And if you don't do this, some marketplaces or exchange web page, exchange services lose their some of their cold and hot wallets. So it is a good idea to have multi-signatures for them. 2 of 2, smart contracts building blocks such as Tumbleweed, CoinSwap, and Lightning Network. And finally, 1 of 3 of 4, distributed backup. So maybe you don't want to lose your private key, so you distribute it in this way to 4, but maybe 1 of them is enough, which is always you. Or if you do this backup with your friends, maybe it is enough to have 3 of them. So with this in mind, let's see how it works in general. So the general form of a locking script setting an M of M multi-signature condition is M. This is the number of people whose signatures is required, and M public keys, which are the public keys of N, and there are M people. Then object multi-sig. So there is an opcode for multi-signatures. Okay. Recall that for the traditionals, it was just a check sig, right? Now it is multi-sig. Where N is the total number of listed public keys and M is the threshold of required signatures to spend the output. So a locking script setting a 2 of 3 multi-signature condition is 2. Here is the number of people required to sign it. So 3 of the public keys are provided here. So any of the 2 private keys corresponding to these public keys can perform this transaction. Okay, that is the idea. So the preceding locking script can be satisfied with an unlocking script containing pairs of signatures and public keys like 0, signature A and signature C, or any combination of 2 signatures from the private keys corresponding to the 3 listed public keys. Okay. So here's how it works. A core secret validation would look like this. Okay. So you start with 0. I will explain why. You give 2 signatures. For instance, in this case, B and C are signing the transaction, and these signatures actually belong to these public keys. So 2 is the M and 3 is the N, and 2 out of 3 signature is verified like this. So you might say that why there is 0 here? And this is due to a bug in actually Bitcoin. So although we say 2 here, the codes in Bitcoin asks to look at +1 signatures here. Okay, so if you write M here, you need to provide M +1 input to the Bitcoin. This is due to a bug, thanks to Satoshi. Okay, so to overcome this is why you put simply 0 to bypass that data. Okay, you can actually write anything. Okay, but it will writing something larger would cause more data to be stored. So we simply put 0 here, and then put the 2 signatures we require. So if it were, for instance, if here, for instance, this tree would be 10, there will be 10 public keys here. And if it were 4 here, I would need to provide 5 inputs. So 0 with 4 signatures. Okay. So a good question would be, why don't we, correct this bug, right? So if this is since the beginning, and we had many updates to Bitcoin since the beginning, Why don't we simply correct the code and remove this line and save those 0 bytes to be stored? The answer is that if you do it, you create a hard fork. So we don't want to create a hard fork. This is why we live with this bug, okay? And the funny thing is that some people think that I'm Satoshi. So they ask ChatGPT if I'm really Satoshi. And ChatGPT says that I'm a well-respected cryptographer who knows the area, but Satoshi makes this kind of mistakes, so I cannot be Satoshi. So ChatGPT thinks that I'm too awesome to be Satoshi, but of course, this is just trying to be politically correct. Of course, this is not the reason I'm not Satoshi, as you can imagine. And this kind of bugs, you know, when you create a huge software, can always happen. All right. So the problems with multi-signatures and why we need Schnorr signatures is as follows. Multi-signature scripts are cumbersome to use. The script has to be communicated to everyone that are going to pay, right? So in this scenario, everybody has to be online, so you have to agree on the signature, so you have to communicate with each other and so on. They have to use special Bitcoin wallet software with the ability to create custom transaction scripts. The resulting transaction would be about 5 times larger than a simple payment transaction because the script contains very long public keys. The burden of that extra large transaction would be borne by the customer in the form of fees. So this is the problem. So for instance, you are the person who wants the money to be transferred to a multi-signature account like this. So the person who is transferring money to you has to include all of these public keys. So the transaction size will be large. So the person who is trying to send money to you will be paying the transaction fees. So you create the problem and your customer pays for it. So this is why we actually use pay-to-script hashes, where you simply pay to script hash, and in that scenario, customer only transfers money to an address that starts with 3. But in that script, you provide all of these multi-signatures and so on. This is why a lot of people think that pay-to-script hash is always multi-signatures, but it is just one way of using it. Okay. A large transaction script like this will be carried into the UTXO set in RAM in every full node until it was spent. All of these issues, so it will, cause to use more memory. All of these issues make using complex locking scripts difficult in practice. So for this reason, pay-to-script hash was introduced in 2012 as a powerful new type of transaction that greatly simplifies the use of complex transaction scripts, because for the customer, you're just transferring money to an address that starts with 3, and that's it. But all of these people who need multi-signatures use those signatures when they want to take the money back to themselves. So during that script, they have to provide it. So now not the customer, but the address owner pays for the fees in that kind of transaction. So one way of solving this problem is this, but thanks to Taproot upgrade, now we have Schnorr signatures where everybody can aggregate their signatures, private keys somehow. So at the end, it looks like as if only one person signed it, but actually that signature belongs to the aggregated signature of all of the signers.